Okay, students, in this class, we will speak about the different types of displacement time graph, velocity time graph, and some acceleration time graph. Let us understand the shape of displacement time graph and understand the motion. For which, let us draw a displacement time graph, which is initially like this is time and this is displacement. And if the displacement time graph is like this, in this case the displacement time graph is a straight line parallel to time axis. If the displacement time graph is a straight line parallel to time axis, what we can understand from this graph is, as the time is changing, the position is not changing. As the time is changing, the position of substance is not changing. Therefore, in this case, the velocity of the substance is zero. In this case, the velocity of this particular substance, it is zero. If the displacement time graph is a straight line parallel to time axis, you can understand the velocity of the substance is zero. That is, the position is not changing. Okay, then let's draw another displacement time graph. If we are having a displacement time graph where this is time and this is displacement, now if the displacement time graph is like this, in this case the displacement time graph is a straight line. It's a straight line, but it's not parallel to time axis. It is making an angle with the time axis. Let's say this angle is theta1. From this graph, what you have to understand is the average velocity and instantaneous velocity in this case will be equal. The average velocity and instantaneous velocity is equal means we can understand the velocity of the motion is a constant. In this graph, the velocity, it will be constant. The velocity will not change, or the rate of change of position is constant. Rate of change of position is constant. In this graph, velocity is constant and rate of change of position is constant. Let me call the velocity as v1. V1 is a constant. Then if I'm drawing another graph in this system itself, that is, if we are having a displacement time graph, if we are having a displacement time graph which is a straight line like this, this is our second graph which is making an angle theta2. This blue color graph is also a straight line. Since it's a straight line inclined to time axis, we could say this is also a graph of a substance with a constant velocity. Therefore, v2, that is the velocity of the second graph, will be also a constant. Velocity will be a constant. What's the difference between v1 and v2 then? You could see theta1 and theta2, the angle made by the two graphs. As we know, slope of displacement time graph, slope of displacement time graph will give you velocity. Slope of displacement time graph will give you velocity. You can take tan theta1 and tan theta2. Since theta1 is greater than theta2, tan theta1 will be greater than tan theta2. That means we could say tan theta1 is, it's not tan theta1, tan theta1 is less than tan theta2. Is this clear? Since theta1 is less than theta2, tan theta1 is less than tan theta2. Therefore, tan theta1 will give you v1. v1 will be less than that of v2. Okay. Then, for your understanding perspective, if I am drawing another graph like this, this is also a straight line, and if this angle is theta 3, you could see theta 3 is less than theta 1 and theta 2. Therefore, we could write tan theta 1 is less than tan theta 2 or tan theta 2 is greater than tan theta 1, but the tan theta 3 value, it will be much smaller than tan theta 1, tan theta 3. Then we could say V3 is the smallest in this three graphs. Therefore, slope of displacement time graph will give you velocity. And the other thing that you have to understand is, if the displacement time graph is a straight line inclined to time axis, then velocity will be a constant. Then the displacement time graph with a greater slope will have greater velocity. Among these three graphs, it is clear that theta 2 is greater than the two angles. Therefore, the velocity of the red color graph is greater than the other two. Okay. Now we know that also. Then let me draw another displacement time graph. If I am drawing a displacement time graph, which is like, let me draw like this. Now this is a curve, it's not a straight line. And if the displacement time graph is a curve, the average velocity will not be equal to instantaneous velocity. That is, the velocity will change at every instant. Therefore, in this case, the velocity is not a constant. Velocity is continuously changing. If the velocity is continuously changing, the idea that we were getting was instantaneous velocity can be obtained by drawing tangent to the point and finding out the slope. If you have to find out the instantaneous velocity at this particular point, you will have to consider a tangent from this point and you will have to take the slope. Let me write theta 1 is the angle of this tangent. Then tan theta 1 will give you the instantaneous velocity at this particular point. Then if you have to find out the instantaneous velocity at this particular point, you will have to consider a tangent from this particular point, a tangent from this particular point. Then you will have to take the slope of this tangent. Let this black color line makes an angle theta 2. Then tan theta 2 will be giving you the instantaneous velocity at this particular point. What about tan theta 1 and tan theta 2? It is clear that theta 2 is greater than theta 1. Therefore, tan theta 2 will be greater than tan theta 1. That is, V2 will be greater than V1. That means as the time is passing, the velocity is increasing. The velocity at this point is lesser than the velocity at this point, or in other sense, as the time is passing, the velocity will get increased since the slope of tangent is getting increased. Okay. Therefore, in this case, what we can say is velocity is not a constant, and we could specify this as velocity is increasing. In this case, the velocity is increasing since the slope of tangent is getting increasing. Okay. Therefore, if the graph is a curve like this, if it is curving upwards, the velocity is also increase. Velocity is also increase. Now we know about this graph also. Then let's draw the displacement time graph of a different shape. That is, let me draw the displacement time graph over here. Time displacement. Now, if the graph is like this, in this case also the graph is a curve. In this case also the graph is a curve. In this case, if the curve was curving upwards, in this case the curve is curving downwards. The red color curve is curving downwards. If the Displacement time graph is a curve which is curving downwards. Then in order to find out the slope at this particular point, we will have to consider a tangent from this point and the angle made by the tangent, let me call it as theta 1, it will be giving you the slope. And if we have to find out the slope at another point, let's say if we have to find out the slope at this particular point, then we will have to consider a tangent like this, a tangent like this. Imagine that this is a straight line, a tangent, then the slope of the tangent will give you the tan theta value of this tangent will give you the instantaneous velocity at this particular point. From this diagram, it is clear that the theta 2 value is less than theta 1. Therefore, the tan theta 2 value will be less than tan theta 1. Therefore, V2 will be what? Less than. I've made a mistake. Let me rub this. In this graph, what we can understand is which is greater, theta 1 or theta 2? Theta 2 is less than that of theta 1. Therefore, tan theta 2 is less than that of tan theta 1. Therefore, V2 is less than that of V1. Therefore, in this case, as the time is increasing, the velocity is decreasing. The velocity is getting decreasing. Therefore, in this case also, the displacement time graph is a curve. If the displacement time graph is a curve, we can say velocity is not a constant, and we could add one more data to it. The velocity is not a constant, and in this case, the velocity is decreasing. This is the displacement time graph of a substance whose velocity is getting decreased. Therefore, the idea that you could aggregate from these graphs shape is, if the displacement time graph is a straight line parallel to time axis, then the velocity will be 0. If the displacement time graph is a straight line parallel to time axis, then the velocity is 0, tan 0. The slope of this line will be tan 0, and tan 0 is 0. If the displacement time graph is a straight line inclined to time axis, we could say the velocity will be a constant. Velocity will be a constant. Depending upon the slope of these lines, we could find out the velocity, and thereby from these three graphs, we could say the theta 3 value is smallest, then it is theta 1, and theta 2 is the largest angle. Therefore, tan theta 2 will be highest, that is V2 will be the highest velocity. This graph will have the highest velocity, that is the second graph.